Welcome everyone to the Medical and Design Manufacturing webinar. I'd like to mention that we have a Q&A following this webinar. So if you wouldn't mind just chatting your questions into the chat window and we'll answer those at the end. My name is Rich Baraki. Joining me today is Joel Blake and Jim Whitney. In case you're not familiar with marketing tech, we specialize in finding manufacturing solutions for OEMs in Western United States. Been in business for over 40 years, and we've helped bring hundreds of products to the market, more likely thousands. We've been long-standing partnership with US-based manufacturers, plastics, metals, and electronics. Today, we're sharing our inside knowledge and tips on medical part design and manufacturing. Now I'm going to hand this over to Joel, and he's going to tell you a little bit more about marketing tech's medical manufacturing experience and expertise.
Hey, thanks, Rich, and hi everyone. I'm Joel Blake. Haven't been with marketing tech for all 42 years of its existence, but I did have my 10-year anniversary yesterday, actually. So I've been in this business a little while, and our company, as Rich mentioned, has supported hundreds of medical device launches. Listed here on the screen are some core manufacturing processes that we specialize in. Some of these will be plenty familiar to you and your teams. Others you may not have worked with before. So we kind of bucket these into three categories: plastics, electronics, and metals. In the plastics world, we have traditional injection molding, which many of our customers are familiar with. Some more specialized processes like reaction injection molding, or RIM, and structural foam molding. Each of these plastic processes can play a role in medical equipment development. It just sort of depends on the size, appearance, and function of the part that you're designing. We do support a range of electronic manufacturing, which you can see some of the categories here. First is user interface, which is a critical area of development, and in many cases it gets overlooked or put on the back burner until the end of development, which we think is a mistake, because to most of your customers, the interface of your product is the product. So think about how you operate on your phone or any other product. If the interface fails or is a little wonky to operate, you remember the whole product as that experience. And then on the inside of the device, we do all different sorts of electronic assembly, box builds, including printed circuit board assemblies, cable and wire harnesses, as well as EMI, RFI shielding solutions. And then the last bucket that we talked about is metalworking. So we do several types of metal forming and fabrication, including casting, a few different processes within casting to cover different part volumes and material needs. And then we work with all things sheet metal, from precision laser cutting to stamping to complete fabrication services. And then with any of these processes in the medical world, we wouldn't be able to launch medical devices without a successful paper trail and stacks of paperwork along the way. So you often need specialized certifications to launch a medical device. ISO 9001 really has turned into the industry baseline for all of manufacturing. Most medical devices that we work on require ISO 1345 certified quality systems. Often you require registration with the FDA for the facility where your device will be built, or the product itself could be stamped with the FDA. And then different manufacturing facilities have also clean environment and clean room standards for how they are manufacturing medical devices. And now I'm going to pass it over to Jim Whitney to share our agenda for the webinar.
Well, thanks, Joel, and welcome everyone. I just got tired listening to that list, Joel. Forgot how much we can do. Let's get into it. You've got questions, we answer questions. It's the core of our involvement with customers like you in medical and lab product development and manufacturing. We want to know about the form, function, and fabrication methods you'll employ, which in turn lets us help you choose materials, processes, and how a part's manufactured. We'll share medical manufacturing examples, including lab devices, with key takeaways for future projects. And as promised, we'll have a gift card drawing and Q&A session at the end. Don't forget to pop your questions into the chat window. Now let's move on to the questions. Where to start? What are the core questions you'll hear from us? Does form matter? Appearance, user experience, and product lifespan? What are the product functions? Operating environment? The physical restrictions? We've never had anybody say, make it bigger, make it heavier, make it uglier. Just haven't heard those. We'll also ask how to fabricate what you need. We'll share several examples to illustrate processes and material selection. Let's show you with the 3 W's. So the first is, who is the primary user? Is it a technician, professional such as a doctor or dentist? Is there a user at all? Or is the product connected and not touched again? Is there one primary user or many? Is weight a concern? Will the user be gloved? Is the equipment customizable per user? These questions help us understand what interface you'll need. What is the primary use? Is it a single-use device or piece of equipment? Will there be many procedures? Will it require sterilization? Is it passive, such as filtering air, providing power, just a box in a corner? Or active, used by the doctor when attending to a patient? These items point to ergonomic requirements, such as, is it a hand tool? Is it fixed? Can it be multi-position? Again, it's all about the use of the device or piece of equipment. Where will the equipment be in use? Ambulatory, in an OR, in a doctor's office? Constant environment or large variations? These questions point to materials, how parts are attached. Will shielding be required? And now a critical item in lab and med equipment, the appearance. Quite a bit of our time spent on appearance, both in development and in production. Many of our questions will revolve around the long-term use and expectations over the use of the product. Many of these areas are subjective, which leads us to quite a bit of qualification around product cosmetics. Out of the box, in use, mid-service life. Is it important that the product have sharp lines or curves? Does it have to match up with the company's other products? Or are they looking for an entire new design? The BioNano Sapphire genomic mapping device, which you're seeing on the screen, is a piece of lab equipment using disposable nanochannels, or some refer to as assays, that are placed under the flip-top door for reading and analysis. You can imagine the challenges. A device that's hundreds of thousands of dollars out of the box, it gets used hundreds of times per day. Much time was spent on cosmetics, how to clean, will the finish stand up, can the company branding be prominent? It is prominently featured on their website landing page. Our suppliers spent days of time with BioNano on part design for finishing, a key cost and design driver. So I touched on user experience above. We all evaluate this. Every time we pick up our phone or type on our keyboard, we're interacting with our device. And when it works as designed, we don't think about it. When our text is autocorrected and sends out an embarrassing note, we curse. My partners on this webinar can confirm I do that. Do you need a touch screen? Mechanical buttons that actually click? Does the equipment operate in a wet environment? Is the interface corded, wireless? Do you need a cradle on the equipment? Most of the designs we work on have custom controls of some sort, and as much time is spent there as is on the overall cosmetics of the product. Lastly, ergonomics are important to assure ease and accuracy of use. As an example, surgeon operating a robotic device needs to have 100% confidence when driving the robot. We work with customers on defining overmolding, soft touch paint, rubber soft feel areas on parts. They improve the feel of a control, as well as achieving favorable cost and performance. Now I'll turn it over to Rich to discuss function. Take it away, Rich.
Thanks, Jim. That was great. So for function, we want to talk about the different operating environments. Kind of range of temperatures are we in? Is this something that's inside in a stable monitored temperature? Or is it outside where it could see pretty, fluctuating temperatures between seasons or even just the time of day? Any issues with fluid ingress? Will the equipment be operated with gloves? That's something that a lot of people might overlook just because you want to jump to a touch screen, but as Jim mentioned earlier, maybe the right fit if you have a lot of multiple layers of gloves on for different reasons, that a mechanical feedback from a mechanical switch might be useful. Any EMI RFI shielding requirements, the chemical resistance for cleaning. So is your equipment going to be routinely cleaned, and the harsh chemical compounds that they use, that just should be considered when selecting the right materials. Is there a need for a battery backup? So if this is a critical device that a power surge in a hospital could affect the performance of it, maybe a battery backup makes sense. Moving on, we want to talk about the physical requirements. Is this a stationary device or is it mobile? Are we moving it from room to room, or is it just going to be installed and sit there until it's retired? Is there any weight requirements that we need to take into consideration? An example that I think Joel will talk about in a moment is a weighted base. So does it make sense to have a casted metal base to lower that center of gravity and prevent it tipping if the device has to run over a cord or something like that? Any strength or impact resistance to consider. If it is a mobile device and it's moving from room to room, does it make sense to toss some bumpers on it to make sure that the door wells don't bang it up? As far as size constraints, if it is a mobile device, is it going to make it through the door? Will it make it around corners? These are all like questions that we should be considering when working up to our design. Robotic requirements, and how are we going to integrate this device with multiple systems? I'd like to hand it back to Joel to talk a little bit about the fabrication.
Yeah, thanks, Rich. We're dropping a lot of F words on you today. Not all of medical device development is an F word, but you might have a couple along the way. We've talked about form, function. Our last one is fabrication. So we've got some process topics listed here. I'll cover these briefly. We probably could do a whole webinar on each of these bullet points here because they're so important. But I'm going to fly through these just a little bit so we can focus on our real world case study with different fabrication examples as well. So many of our customers start out thinking of fabrication as the physical production of their device. So, they picture manufacturing lines, assembly lines, the actual parts coming to life. But in reality, fabrication needs to be an overarching consideration of the whole development cycle. You're coming up with designs on a CAD screen. Your design looks beautiful in SolidWorks, but how are you going to take that and turn it into a tangible product? You have to know pretty early on in your development process what sorts of manufacturing could make sense and narrow it down so you can design effectively for those processes or that process. And that's where design for manufacturing comes into play, or DFM, you'll commonly hear it referred to. Many of our customers who we find are the most successful at this are starting to involve their supplier partners early. So they're looking at the process selection, maybe even at the concept stage of their device, narrowing down which processes could be used, and then they're involving their prospective suppliers to help them with technical guidance throughout development. Because the earlier that you can get the experts in one process involved in your component, the more you can focus on being the expert in your product, which is really what your job is. You don't want to have to be an expert in every manufacturing process in addition to the product that you're working on. And then so once you know how each component's going to be manufactured, you can work with those supplier partners to optimize the tooling approach and come up with a production plan that will meet your schedule requirements and meet your ongoing sustaining delivery requirements for the lifespan of the product. So, you know, if you were working on a consumer product, your product might be touched or adjusted or upgraded every 12 months. You know, we talk about an iPhone as kind of the ubiquitous example. That's not the world that we're playing in here. Most of the medical devices that we support are intended to be in the field and in production for, I would say, minimum 10 years, often as high as 20 to 25 years. And so that changes your approach in terms of fabrication. You need to take those timeframes into consideration. Okay, so this is a fun part for me. We like to talk through a real world example of a medical cart that our team got to support with a number of different manufacturing technologies. So you can kind of see the cart on the screen here, but it's obviously a 3D rendering. This isn't the actual product. We wanted to protect client confidentiality, but the components that you see pictured around the cart are the real deal. So I'll walk through these and I'll talk through some of the considerations that went into the fabrication process selection and how these parts ended up being made and why. So starting at the top center of the cart, you've got the user interface. We've hit on that a little, probably more than you expected, because we run into so many customers that save the interface design and development for last. And because it's such a critical component of your customer's experience, we recommend getting ahead of that early on. This particular cart has what we consider a hybrid interface. So you have a touchscreen display that's handling the bulk of operation of the cart, but then you also have a membrane switch panel on the front that's complementary. It handles certain select functions of the cart, and that's going to have more mechanical feedback, like if the operator is wearing gloves. You don't have to worry about, you know, splash resistance, like if it's in an operating room, those types of things. So there's advantages to both levels of interface. And then clocking to the right here, we've got an image of one of the printed circuit board assemblies that lives inside the cart. So this cart has about a dozen boards inside of it, and then some sort of box build sub-assemblies that also include cable and wire harness assemblies and some components and coatings to apply for EMI RFI shielding protection. And it is pretty common in a cart like this for there to be multiple types of shielding needed. So in this case, you've got some seals and gaskets that have inherent shielding built in. Those are applied around select electronics to protect those. And then you've also got a spray EMI RFI shielding that's applied to the inside of the plastic enclosures of the cart that's helping with shielding. Now, just moving around, you're going to see a number of various mechanical components here, some metals and plastics. The first one we're looking at is titled the overmolded handle here. It's actually a hybrid of a metal and plastic process, because you've got the base portion of the handle is cast, it's cast aluminum, and then the center portion there that you see is overmolded with an elastomeric or rubber-like plastic that gives it a nice soft touch feel on the handle when someone's operating the cart, pushing it around the hospital. So this handle gives it both the strength, the high appearance, and also the nice ergonomic feel for someone pushing the cart around. This type of elastomeric material, I just wanted to mention, is often used for bumpers on medical equipment as well. So when something's being pushed around an operating environment or a hospital or a doctor's office, it's common to run into things, and a lot of times you might need some rubber-like bumpers surrounding the bottom of the cart, or whichever section of the cart is protruding and running into walls. Next component to the right is the cord wrap. There's 4 of these that appear on the back of the cart. Kind of looks like a glorified vacuum cord wrap, but it serves a pretty important function, because this cart in particular has some heavy-duty cords that are used to power it and plug it into the power source. And those need to be kept out of the way when someone's pushing the cart around. And so the customer needed strength of the cord wrap. They don't want a plastic piece that's going to be breaking off with continued operation. So they elected to go with a die-cast aluminum cord wrap. And then we applied a nice cosmetic finish there with some directional arrows silk screen onto the cord wrap. The next component over is a bigger plastic component. It's actually got a, so it's a rim molded housing, but it's actually got a laser cut sheet metal vented section in the middle that's insert molded into a rim part. So that gives you the nice complex venting pattern that was required for the airflow and the heating and cooling of this particular device. And then the whole assembly gets painted to unify the look of it and make it a nice cosmetic match with the rest of the cart. And then Rich talked about bases a little bit. So this cart has a nice cast base on it. You know, this provides a number of functional components to the cart. You need a little bit of weight in your base typically to handle the weight distribution, so you're not, you know, tipping over the cart when you're pushing it over a door threshold. But it also needs to be a nice cosmetic base because it's customer facing and it's a big part, and it's one of the first things you see when you walk up to the cart. So we used a nice cosmetic casting process here. It's a sand cast base. We did it in zinc to give it a little bit of extra weight, zinc instead of aluminum. It's a denser material. And then we were able to apply a nice cosmetic paint onto it after casting. And then just clocking around, you see a sheet metal component that is a storage tray in the front of this cart. Fairly basic fabricated component, but it's got some complex weld requirements. And whenever you're dealing with high cosmetic requirements of medical devices, you know, anytime you have welds or assembly, a lot of touch points on a part in manufacturing, you really have to manage the cosmetics of it and plan for the cosmetic finish that's going to be applied. And that's what we did here, so that the cart, or the tray here is a nice cosmetic match with the rest of the cart. And then we're also just referencing a chassis here. The interior of a medical device like this will often have a frame or a chassis, we call it, that's starts as a sheet metal assembly or weldment, and that's more of like a structural assembly that would be running throughout the cart for stability. It also allows for the chassis typically is where the plastic components attach, so there's various forms of hardware and things that are used to accomplish that. And then the final piece pictured here in the top left is a structural foam enclosure. So structural foam is another somewhat specialized plastic molding process. It's a lower volume injection molding, lower pressure and also lower volume injection molding process that's ideal for larger, thicker, highly structural parts that need some impact resistance. And then the parts get painted also to unify that cosmetic finish across the device. So that's what you're seeing here. So we've thrown a lot of information at you in a short period here. So what should you take away from today's discussion? Really, we think it's more about asking the right questions than having all the answers when you go into a new device development. So we've given you some guiding questions. You know, this is by no means an exhaustive list that we've given you here today, but I hope it's food for thought for you about the major buckets that you need to be considering of requirements for your device. We group those into 3 F categories: the form, function, and fabrication of the device. So with form, who's going to be using it, what's the primary use, and where is it going to be used? That's the starting point. And that's going to dictate the look of the device, the footprint of the device, how the user experiences using your device, which is such an important component. The function of the device takes into account all sorts of requirements of operating environment, the physical requirements, the temperature swings, storage and transportation are some of the often overlooked pieces of development with these devices, especially if you're working with a larger footprint or larger envelope unit. You know, sometimes it takes some pretty extensive development on custom packaging used for transporting this big, heavy device around the country or the world in many cases. Where's the device going to be stored? Is it going to be in a warehouse in Texas in the summer, or is it going to be, you know, stored in Alaska in the winter? These are all things that you have to be thinking about throughout the development process. And likewise with fabrication, the earlier that you're thinking about fabrication, even from the cocktail napkin sketch phase of your development, you've got to be thinking, how do we not only design this beautiful part, but how do we manufacture it in the most efficient way? because anything can be 3D printed once or twice, but when you're running something that even is as high as dozens per year up to hundreds or thousands per year on your device volumes, you really need to look at more scalable, more sustainable solutions. And then we encourage you to partner with medical manufacturing experts. So that could be specific suppliers when you narrow down your process selection, working with your process experts at those suppliers to optimize your designs. And it could be working with rep firms like us who work with a lot of different processes, because we get to see best practices throughout the industry and help younger companies who may not be as experienced with these types of developments parlay that knowledge that's already around the industry into successful device development. And I just want to throw in a plug that we love doing presentations like this and discussions with design teams. We do a lot of customized lunch and learns. We did a great one recently that focused on 2 separate processes, both the plastic cosmetic enclosures and the metal cosmetic castings that were required on a device. So please feel free to reach out if we can support your team in that way. And now I'm just going to pass it back over to Jim to round us out.
Thanks, Joel. Great info and great examples. And I can't reiterate enough the value of us coming to your facility, doing a custom presentation, reviewing designs you have that are real life. That's kind of our lifeblood and what gets us excited. So I want to thank you all for joining us today. Now for the rewarding part of our webinar. We appreciate you spending your valuable time with us. We're going to give away a $50 gift card to 3 of today's attendees, either to the restaurant of your choice, or if you prefer, the charity of your choice. We'll jump into the question and answer session just after this. Don't forget to send your questions to us via the chat window to the right side of your screen. And now for the winners. By the way, we're going to keep the last names private so that they don't get overrun by their office mates looking for a free lunch. The 3 winners are going to be Steve B, Paul P, and David C. And we'll reach out to you after today's webinar for details on how to get you your gift. Now, Rich, let's hit the questions.
All right. Yeah, looks like we got a couple here. This is a great question, and it's something I feel like I get asked at least half a dozen times a day. Jim, I feel like this might be a good one for you to answer, but you let me know. How do you design around material availability and lead time issues?
Yeah, because there's none of those.
You ever heard that question before, Jim?
No, never. No, that doesn't happen. I have a project in the works right now. Was quoted Monday of this week, and the tooling schedule, it's for injection molded components. The tooling schedule matches right up with what the customer needs. It's the first parts for validation that are going to kill them. So we're working with them early on to get the materials specified, although they're pretty locked in to a certain category. The materials have to meet FDA requirements. They have to be certain colors. They have to be a certain PCABS. But we're able to get orders in place early, not for parts, because this particular customer is handcuffed. They cannot order any parts that are not approved in their system. It's one of the curses of larger companies, but there are reasons why this is in place. But we are able to work with them and, calculate how much material is going to be needed, kind of overestimate so that there's some excess available, because if anybody's worked on an injection molding project before, they know that, there can be challenges. We have to rerun parts. But we're going to get that material ordered at the same time the tooling is ordered versus waiting until parts are approved, because with lead times on some materials today extending to 12 and 14 weeks, we're getting tools built in 6 to 8 weeks. And then we have to more than double that time to get production parts. So we're going to get the material on order immediately. We will short circuit that extended lead time and have that material available when it is time to go ahead and sample tools, do a form, fit, and function test on the parts. The customer will be there when tooling is tested, and if they're functioning, they will approve us to go ahead and run 500 of each part for their future testing and validations. So we don't get by that long lead time. So great question. Everybody's facing it. And it's not just the plastics industry, but it seems like plastics is being hit by it a lot. So thanks. Great question.
Yeah. Just to echo kind of what Jim said, I really think a lot of it just comes down to planning, understanding the hurdles you're up against and planning around them. We got another question. So what are some more examples of where structural foam enclosures are used? Joel, you have any comments on that?
Yeah, we've done a surprising number of structural foam projects over the years. One advantage of it compared to some other lower volume plastic processes is that the piece price is really attractive on larger enclosures. So when you have the tooling's a little bit higher when you compare to something like rim or thermoforming, but then the piece price is superior. And the advantage in the medical device world with that is if your device is expected to run a long time, which a lot of them are, in the decades is how we measure a lot of product life cycles in medical, you can afford to spend a little more on tooling on the front end to get your cost of goods down. And so structural foam is really useful for that. Typically I would say the majority of what we've done with structural foam has been highly cosmetic. We happen to work with a molder with that process who has in-house paint, so they have complete control of the process. They have in-house shielding application, so they can deliver the parts molded and fully finished to the customer, where the customer is not having to buy a raw molded part and ship it to another paint shop to get it finished, which is a big advantage. So we do a lot of highly cosmetic structural foam components, and that's everything from doors to panels to trays that go on a card. You can do really highly cosmetic, complex shapes, and larger, thicker parts. So the wall thickness in structural foam is usually around a nominal wall of about 1/4 inch, compared to injection molding. If you're trying to achieve that thickness, you run into the possibilities of sink and things like that. So it's a really nice process. It's pretty ideal for volumes in the 300 to 500 per year range up to low thousands is kind of where structural foam plays. And the other thing I'll mention about it is it's actually a pretty structural process. So the material that we typically run is a Noril in that process, and that type of molded structural foam part actually has a higher strength to weight than aluminum. So it can be used to replace a sheet metal weldment, for example, consolidated into a single molded component and handle some structural load within the device, in addition to the outer cosmetic enclosures.
Wonderful, Joel. Thank you. And yeah, I can say structural foam is a great process. And in 40 years, when I have some clout, I'll try and change the name of the industry, because I don't love the name of foam when structure is right next to it. But it truly is a great process, and it really helps a lot of our customers. Looks like we have another question. How do you match color and texture for metal and plastic parts from different suppliers? Jim, any thoughts on that?
Yeah, so we have a great question. We have a couple of examples of projects we've worked on over the past few years where there are parts that are aluminum casting, and then they match up to either structural foam, sheet metal, injection molded part. And again, we talked earlier about out of the box appearance. People that sign off on purchase orders for something that costs $500,000 or $100,000 or even $10,000, when it comes out of the box, it's got to look good. It's got to look like they made the right decision. And one of the things that happens is you can use the same specified paint, but in two different facilities on two different kinds of substrates, and almost guarantee that they will never look exact, other than if you are able to get those painted in the same shop with the goal of having the appearance to match from the cast part to the metal part to the molded part. So we have an example where our aluminum sandcaster ships parts to our rim molder, who is an expert finishing shop along with being an expert rim molder. And those parts get painted in sets on their line. They will work with the customer to specify certain primers that will work on both materials, so the paint takes the same way. And really, it's the final inspection that's identifying, hey, these parts match, and they were painted at the same time in the same facility with the same paint. You've just increased your odds 100 times that you'll get those parts to match. So, one example is the aluminum casting to the rim molder. The other is our sheet metal fabricator up in Minneapolis, Harvey Vogel, does the same thing. They will take in parts that are either plastic or cast and paint them at the same time on the same powder line to just get a consistency of finish, which is texture, sheen, the depth of color, all done at the same time, and just has turned into a very successful approach for color matching, which is a cosmetic requirement, and it's something, again, when a $100,000 device comes out of a box, people expect it to look exact. So great question, a real life problem, and we can help you solve that.
Looks like we've gone over a little bit on time, and there are a couple more questions, but we'll address those via email and let everyone get back to work. If there's any last comments from Jim or Joel?
Just want to thank everyone for being here. We know you have various content to take in. It seems like we had a pretty overwhelming level of interest in this topic, so I hope we were able to deliver some useful information to everybody.
Yeah, I'll mirror Joel and say thank you very much. Please don't hesitate to reach out, and we'll follow up with you after this just to get you any information that may have come up or answer any questions you may have had that we didn't get to answer here. So again, thanks for spending your valuable time with us.
Thanks, everyone.
Good one.
Thanks.